Hello everyone, we are a team from Earl of March.
There are two members on our team, me and my sister Alice. Alice mainly worked on the Agility Challenge, and I mainly worked on the LRT Detour Challenge.
Our initial strategy was to use a robot from First Lego League and then install big wheels on it to make it faster. We decided to program smooth turns like a real race car. We used Lego EV3 steering blocks for the program. Our hypothesis was that the steering blocks would work well for us. We tested each arc individually and then we tested our whole program together. After the test, we created the accelerate block that would accelerate the robot because we noticed that the wheels would slide when the robot starts to drive with high speed. Then we created my steering block, which would do the same thing as the normal steering block, but it won't slow down at the end. And we created my gyro steering block to improve control and speed of the robot. This is our final program. The begin block waits for 3 seconds, starts a countdown, starts a timer, and starts the program. That accelerate block accelerates the robot. The my gyro steering blocks would do the arcs, and my gyro steering light is the same thing as my gyro steering, but it would look for the line at the end so it could stop. Then the end block, you could see how much time it took for the robot, and it stops the program. This is how my gyro steering works. Let's say the robot needs to drive an arc which is 90 degrees, and the the robot is facing 0 degrees. You would put it over here. Then then the ending position is negative 90 degrees. You'll put it over here. Over here you'll put the speed. And let's say the distance is 5 rotations. You would put that over here. And first you'll drive 1 rotation, and that would be 1/5 of the um, arc. And then because the it's 1/5, you need to find out 1/5 of the angle, which would be 18 degrees. You would figure that out in this red math block. And then I'll pass on the information to gyro control that would turn the robot.
This is the gyro control block. We made it several years ago when we are preparing for Skills Ontario. Uh, what this does is it follows a fixed angle using a gyro sensor, kind of like following an invisible line. Um, so it takes an input angle, then it finds the difference between the current angle and the target angle, multiplies it by the proportional coefficient, which gives us the power adjustment for the motors. This then gets subtracted from one motor and added to another in order to turn the robot back to the desired angle.
This is our FLL program that we did. We used gyro control in it. Right over here, we used gyro control to go straight. But in our next competition over here, we went farther and we used gyro control for actually doing arcs. This is the begin block, the accelerate block, then 90 degrees, 180, 270, 180, another 270, another 180, another 270. And the last one is my gyro steering light because it needs to stop at the line. Our strategy worked pretty well. The program based on the gyro sensor is complex, but it's very fast and accurate. The gyro sensor sometimes drifts, but if you turn off Bluetooth, then it will drift less. And if it still drifts, then you could unplug the gyro sensor and it'll stop. And you could see that in the begin block. Then the program based on steering blocks is simpler, but it's slower.